This program is brought to you by the Ministry of Education and Vocational Training Zanzibar in collaboration with Good Neighbors. The program is funded by KOICA.
Dear listener, you may learn so useful issues in this program as far as you will pay your attention to listen. However, our program today is specially for Form 4 physics learners. The program will provide free discussion on A. The concept of wave. A. The concept of wave. B. Types of wave. B. Type of wave. C. The wavelength, frequency, and velocity of a wave. C. The wavelength, frequency, and velocity of a wave. And D. Self-assessment is allowed while the program is going on. For our lovely teacher, the program will help you to prepare a simple lesson for your students so that they will learn with joy, improve their performance and competence.
Yeah, can you show me the crests or the troughs?
Look at the top of those coming waves.
I see them. They are very high.
Yes, those are the crests or troughs.
Okay, now I understand better about the crests and troughs.
When you are with the real things, you can always learn better.
It's true. Look now.
Uh-huh.
We are here at the beach and see with our own eyes on the crests or troughs and the frequency of a wave.
And the velocity of the wave.
Yeah. Have you seen the wavelength?
Okay. Can you tell me the meaning of crest, trough, wavelength, frequency, and velocity, please?
Yes. These terms were explained in our previous program.
Wonderful. You are so genius.
Thank you. And think about this while you are looking.
Uh-huh.
Wavelength is the distance between two successive adjacent crests or troughs.
All right. I get it now. That distance between the two tops of the waves is called wavelength.
Exactly, Musa. It looks like the wavelength varies directly with the speed of the wave in the same medium.
Yes, but it seems in a fixed medium where the speed of the wave remains constant and the wave's length varies inversely with the frequency of a wave.
Okay. Varies means kutofautiana. What about inversely?
Inversely means in opposite order, but I don't know it in Kiswahili.
That helps a lot. Thank you, Musa.
Thank you too.
I think the maximum amount of displacement of a wave depends on the amount of energy being transmitted.
Okay, so that means a decrease in the maximum amount of displacement or amplitude of a wave, it shows that the wave has lost some energy. Length,
Yeah,
look
that's
higher.
why some waves change the speed.
That's true, Salma. And I think waves change its speed as a result of the change in the medium or the condition of medium in which the waves travel.
Look at these water waves now. I totally agree with you.
What happened?
I swallowed some water accidental.
Oh, sorry. Be careful with the wavelength. But are you alright? Oh, would you like to go out of the water?
No, I'm fine, thank you. I agree with you because I also think that a change in the speed of the wave results in a change in the wavelength of the wave.
I think so too. And it seems waves have different properties, don't they?
Obviously, yes. This means that there are changes in different properties of waves too.
Yes, it seems there are changes in different properties of waves, which causes different behavior of waves.
Behavior of waves? Like which one?
Let's find out.
Okay. Okay. Musa,
Yes?
look. The waves bounces against the rocks and seem kind of change direction.
Yeah, that's right. Do you know what is that?
I have no idea. What that?
That is a reflection. Do you remember the reflection of light?
I do remember. So that is a reflection of waves?
Yes, a reflection of waves. And it is a behavior of waves.
Alright. And if reflection is a behavior of waves, then refraction, diffraction and interference are also behavior of waves.
You are right, Salma. Behavior of waves is reflection, refraction, diffraction, and interference.
Musa,
Yes?
as I look at the waves, it seems that reflection takes place at the boundary of the medium or at any point where there is a change in wave velocity.
Good observation, Salma. I also see that how the wave is reflected depends on whether the end of the object at the boundary can move or not.
I see it true. If the end of the object is fixed, the reflected wave will be inverted.
Inverted? What is that?
Inverted means geuzwa.
Okay. Then, if the end of the object is free to move, the reflected wave will not be inverted.
If the reflected wave will not be inverted, then it will have the same speed and the wavelength and the incident wave.
Sure. However, I think the reflected wave will have a small amplitude, showing the wave has lost some energy at the boundary.
Let's look at the water waves and see how that happens.
Yeah, it's true that the reflected wave has smaller amplitude, showing the wave has lost some energy at the boundary.
Yes, I have just noticed something else about the waves.
Okay, you tell me, and then I will tell you what I have noticed.
Alright, when a wave encounters a new medium through which it can pass, part of the wave's energy is reflected, and part of the wave's energy is transmitted through the new medium. When a wave encounters a new medium through which it can pass, part of the wave's energy is reflected, and part of the wave's energy is transmitted through the new medium.
Oh, that's true. And I noticed that the reflected waves had the same speed and wavelength as the incident wave.
Really? That means the transmitted wave will have a lower speed and a shorter wavelength than the incident wave.
Exactly. In that case, each wave will have an amplitude less than the incident wave, since the energy of the incident wave is split between the two waves.
Sure? What if the new medium has a lower density?
I think the reflected wave will not be inverted. It will have the speed and wavelength as the incident wave.
Okay, and I think the transmitted wave will have a higher speed and a longer wavelength. Okay, I think the transmitted wave will have a higher speed and a longer wavelength, and that both will reduce amplitude.
I think so too. And do you think that is also the case in refraction of waves?
I'm not sure, but let's observe more.
Salma,
Yes?
I noticed that refraction involves a change in the direction of waves as they pass from one medium to another due to the change in speed.
I noticed it too. And on top of that, refraction is accompanied by a change in the wavelength of the waves.
I see. Do you know what the speed of a wave depends on?
Yes, the speed of a wave depends on the medium through which the wave is traveling.
Alright. So, does it mean that if the medium changes, the speed of waves changes too?
Indeed, you are clever. What have you noticed?
I have noticed that the wavelength decreases when the water waves travel from a deep part to a shallow part.
That's right. However, I think the frequency of the wave does not change, but the velocity of the wave decreases with the decrease in wavelength.
Alright. Also, I noticed that the velocity of water waves is higher in the deep water than in shallow water.
I see. What I have also observed is that the reflection of water waves can be clearly observed if the boundary between the deep and the shallow regions is at an angle to the incident waterfront. The refraction of water waves can be clearly observed if the boundary between the deep and the shallow regions is at an angle to the incident waterfront.
Wow, that's interesting. Let me observe it too.
Okay, just watch the waves as they move from deep water to shallow water.
You are right, Salma. But I'm wondering, how does the wave interference occur?
If you look at the waves more carefully, you can see that wave interference occurs when two waves that are traveling along the same medium meet.
Okay, I see it now. And it seems that this interference is also the addition of superposition of two or more waves, which results in a new wave pattern.
I understand what you mean, Musa.
Okay.
And I think the resultant displacement at any point is equal to the sum of the displacement of different waves at the point. I think the resultant displacement at any point is equal to the sum of the displacement of different waves at the point.
That sounds like a principle of superposition, isn't it?
Yes, it is. And it means that if a crest of one wave meets the crest of another wave at the same point, then the resultant wave has a greater amplitude.
Wow! Then we can call the constructive interference, right?
Yeah, constructive interference because it occurs at any location along the medium, where two interfering waves have displacement in the same direction. Constructive interference because it occurs at any location along the medium, where two interfering waves have displacement in the same direction.
Alright, if there is a constructive interference, then there must be destructive interference. We watch the waves more closely, we might find it out.
You are right. There is destructive interference. Have you seen it too?
I have, and I think destructive interference occur at any location along the medium, where the interfering waves have a displacement in the opposite direction. Destructive interference occurs at any location along the medium, where the interfering waves have a displacement in the opposite direction.
Okay, I understand you. But I see in constructive interference, we get lines of decreased disturbance. How can we call this line?
We can call them as antinodal lines.
Antinodal lines? Okay. How about those lines that we get in destructive interference?
There are nodal lines. Salma, it seems sometimes the waves pass through one another and result in both constructive and destructive interference.
Yeah, I think so. Musa,
Yes,
now I feel cold. Let's go home.
it's very true. Let's go.
Today I enjoyed the swimming because the waves were high and speedy enough for me to swim around.
I'm glad you enjoyed. What else did you enjoy?
I enjoyed learning the behavior of waves such as reflection, refraction, diffraction, and interference of waves.
That's great. I also enjoyed the swimming and learning the nodal and antinodal lines, as well as constructive and destructive interference of waves.
Good. We can learn everywhere at any time.
Thanks. We just need to pay attention to things around us and make observations.
Okay. Can you distinguish reflection, refraction, diffraction, and interference of waves?
Yes, I can. Don't you?
I'm also too. Anything else, Musa?
Well, I have two things to remember. First is the difference between crest and trough, as well as node and antinode in waves. Secondly, we have to demonstrate the applications of behavior of waves in our daily life.
It's true. We must keep our brain busy, ready, and active on observing things.
Sure. Alright, Salma. I will see you later.
Okay, see you. Goodbye.
Goodbye.
Very good. I was so close to a discussion and I'm so interested. Hopefully, our dear listeners have enjoyed and gained a lot through our discussion. Now, here are the questions about the topic for further discussion. Explain the concept of wave. Explain the concept of wave. Explain the term wavelength, frequency, and velocity of a wave. Explain the term wavelength, frequency, and velocity of a wave. Here is the end of this program, but you are so welcomed in the next program. So, until next time, bye-bye.